Hello everyone, today my lesson will be on the mean value theorem, how to solve mean value theorem problems, how to apply it in real life, and a couple of corollaries to the mean value theorem. To understand it, you must first understand the intermediate value theorem. What this states is that if a function is 1, continuous, 2, defined, and 3, differentiable, on an interval from A to B, then point C must exist. And this is a fairly simple concept. Of course, if a function is continuous, defined, and differentiable, then it goes through every single x value in between A and B. What this says is that there must be a point C in between A and B. Let's say your A is 2 and your B is 4. Your point C could be 3, it could be 2.5, it could be 2.001. All it's saying is that a point must exist. Now that we have a firm understanding of the intermediate value theorem, we can see how it applies to the mean value theorem. What the mean value theorem states is that if a function is, again, defined, continuous, and differentiable on an interval from A to B, then f prime of C must equal f of B minus f of A all over B minus A. And this exactly deals with the intermediate value theorem because, as you can see, we are solving for point C right there. However, this is a special point C. What this equation states is that the average slope from A to B of a function at one point must equal the exact slope at a point C. And to have a visualization of how this applies, imagine this is our function f of x, okay? And imagine this is point A, this is point B, so we have our interval. What the mean value theorem states is that the average slope from A to B, which we can say is approximately this, so this would be your m, must be exactly equal to the exact slope at a point C in between A and B. And from our graph, it looks like this is our point C right here, in which the slope is also m. And so with the mean value theorem, you can solve to find such point. And another thing you can see is that the slope we are dealing with is really similar to our y2 minus y1 over x2 minus x1, and that proves to show that we are dealing with slopes and how to find them, except the curves are more complex. They're not just straight lines, they actually have certain shapes that we cannot just use y2 minus y1 over x2 minus x1. Here's a sample mean value theorem problem. This problem asks us to find C if f of x is equal to x cubed plus 12x squared plus 7x on the interval from -4 to 4. First thing we have to do is to check if all the conditions for the mean value theorem are met. Is the equation defined? Is it continuous on that interval? And is it differentiable? Of course, this is a cubed function. As we know, there are no restrictions on a cube function. There's no cases in which the answer would be undefined. So we do know that 1, the equation is defined, it is continuous, there are no limits whatsoever, and there are no cusps, there are no vertical asymptotes, it is also differentiable. The 3 conditions are clearly met. So now we can move on, and what we will have to do is set up our mean value theorem equation. As we already know, f prime of C will equal f of B minus f of A all over B minus A. Now all we have to do is plug in. As we know, the 4, since it's our greater number, it's going to be our B. The -4 will be our A. So f prime of C equals f of 4 minus f of -4 all over 4, then minus a -4 will give us plus 4. Here's how you can find the y values for our respective x values in our cube equation. you go to your y equals, you type in your equation, which is x cubed plus 12x squared plus 7x, and then you make sure your table set is on independent ask. You go to your table, which is second graph, and you type in our b value, which is 4. This gives us a y value of 284, and you type in your a value, which is negative 4, and this gives us a value of 100. Now, with calculator work, once you plug it in, you will see that f prime of c, f of 4 will give you 284, f of negative 4 will give you 100, and 4 plus 4 equals 8. Therefore, this equals 184 over 8, and f prime of c will give you a value of 23. However, we are not done. We are not looking for the value of the average slope. We're also looking for at what point c in our interval this slope occurs. So, as you recall, our initial equation was f of x equals x cubed plus 12x squared plus 7x. Therefore, our f prime of x will give us 3x squared plus 24x plus 7. And we can manipulate this equation and say that f prime of c will equal 3c squared plus 24c plus 7. Now we have two equations. This is our first one, this is our second one, which equal f prime of c. In terms of c, all we have to do is to set them equal to each other, and we will be able to solve for c. So 23 will equal 3c squared plus 24c plus 7, and 0 will equal 3c squared plus 24c minus 16. So now we must solve for c, and this is the perfect situation in which we can use the quadratic formula, which states that x, when set to 0, will give you negative b plus or minus the root of b squared minus 4ac all over 2a. Of course, our 3 will be our a, our 24 will be our b, and our negative 16 is our c. Therefore, the c values that satisfy this equation will equal negative 24 plus or minus the root of 24 squared minus 4ac all over our 2 times our a, which is 3. As we simplify this equation using your calculator, you will clearly see that c equals negative 24 plus or minus the root. Solving the quadratic formula, we get that 24 squared minus 4 times 3 times negative 16 equals 768 of 768 over 6. And now, again using your calculator, you will see that this yields two separate answers. The first answer focuses on negative 24 plus the root of 768 all divided by 6, and that is 0.6188. The second answer is negative 24 minus the root of 768 all over 6. And this gives us negative 8.6188. The first answer states that c is equal to 0.61880. The second answer states that c equals negative 8.6188. However, if you recall, our interval stated that the function went from negative 4 to 4. This second value is not included in our interval and therefore is disregarded, whereas the first value is clearly inside our interval, and this is the c we are looking for. Therefore, using the mean value theorem, we have proven that the average slope of our given function from negative 4 to 4 is 23, and that exact slope of 23 occurs when c, or x, is equal to 0.61880. You have successfully solved a mean value theorem problem. Interesting way to see how the mean value theorem applies in real life is through the use of daily forecast temperatures. For example, in this diagram, you can see that the daily temperature is predicted to be an average of 84 degrees. However, according to the mean value theorem, there must be also a moment in that day in which the exact temperature at that moment equals the average temperature throughout the day. As you can see, this clearly happens at 10 a.m. when the temperature is also exactly 84. This is the mean value theorem in real life. A special corollary to the mean value theorem is Rolle's theorem. What this states is that if a function is again defined, continuous, and differentiable, and if a special case occurs in which f of b equals f of a, then f prime of c is equal to 0. And the way to visualize this is if we have our graph f of x, which goes something like this, and f of b is equal to f of a, this means their y values are the same at different x values, then f prime of c at some point c is equal to 0. So imagine this is our a, then this is our b. What Rolle's theorem states is that there must be a point in between these two where the slope is 0. And this makes sense because if a graph goes through the same y point, it must have either created a maxima, or if our graph looks something like this, a minima. And as we know, the slope at a maximum or a minimum is 0. So what Rolle's theorems help us do is to solve for this point c, which would be here in this case, where the slope is 0, and it is in between a and b because a and b equal each other. Now we will solve a Rolle's theorem problem. Here's a sample Rolle's theorem problem. If f of x is equal to x squared over 2 minus 6x from 0 to 12, find the horizontal tangent. Okay, as we read horizontal tangent, you should automatically realize it could be dealing with Rolle's theorem. However, the conditions must be met first. Since it's a quadratic function, and there are no restrictions on x values, it's all real numbers, and therefore the function is defined, continuous, and differentiable in the given interval. However, for Rolle's theorem to really apply, we must check to see if f of b is equal to f of a. So, f of 12, as you know, 12 shall be our b, 0 shall be our a. F of 12 will equals 12 squared over 2 minus 6 times 12. 12 squared is 144 over 2. That will give us 72 minus 72, and that equals 0. F of 0 is equal to 0 squared over 2 minus 6 times 0. This also equals 0. Therefore, since f of 12 is equal to f of 0, f of b is equal to f of a, and Rolle's theorem is applicable. Since f of b is equal to f of a, f prime of c at one point c must equal 0. Now we shall solve for such point c. F of x was equal to x squared over 2 minus 6x. Therefore, f prime of x is equal to x minus 6. We can manipulate this equation to get that f prime of c is equal to c minus 6, and according to Rolle's theorem, 0 will equal c minus 6. This gives us a result that c is equal to 6. This is our answer. We know, and here we can answer in words, that the horizontal tangent occurs at c, or x, when it is equal to 6. And it is within our interval from 0 to 12, so we know we have the right answer. This is basically saying that when c or x is equal to 6, the slope of the line will be exactly 0 according to Rolle's theorem.